So, good morning. Today we are going to start our new course. The course name is Programming Methods of PLC, where the PLC is the Programming Logical Controllers. And this course is dedicated learning programming methods of PLC. So, our first lectures is about first and primary information about PLC, and we will discuss about main features of PLC. So let's start our first primary information about PLC. Let's discuss it. So before PLC, the element base of control system was rigid. This is the main idea that we need to learn, because PLC element base is not rigid. The element base developed after it became flexible. So we can say that element base of PLC is flexible. The first PLCs were invented in the United States. In the United States, the first PLC was implemented at the General Motors automobile plant. The first PLC was invented at a company. The name this company was Bedford Associates. So next, primary information about PLC. The first PLC developed at Bedford Associates was branded as 084. The author of the PLC is an American engineer, Richard Morley. So it was the main and primary information about PLC that we need to know. So next information about PLC. In this picture we can see the Richard Morley. As we said, he was the father of modern controllers, and he was the person who developed a prototype of modern PLC. So this is the one of the PLC model which was developed at Bedford Associates by Richard Morley, and this PLC model is PLC Modicon 184. This is not PLC model 084, but this is the one of the PLCs which was developed at that years. So, and we need to know that programmable logic controller is the PLC. So next information about PLC we will talk about on the next slide. So let's talk about automation control systems. And discussing about automation control systems, we will discuss about PLC and its role and place in automation control systems. So in this picture we can see the structure of modern automation control system. So In this picture, we can see the place that the PLC occupies in the automation control systems. So, modern automation control systems, we can divide to several levels. So, at the lower level, it means this levels. At the lower level, there are sensors or instruments and actuators with which the system interacts with the control objects or plant. At the next level, there are PLCs that collect information from the lower level, process it, and then act on the object or plant using an actuators. So this is the second level. So, and third level, at the top level, is a program that implements the HMI technology. HMI means human machine interface. This is the level at the top of the automation control systems, and in this level, system implements the human machine interface. Also in this level, we have computers that implements the human machine technology or programming tool, which we call SCADA. SCADA means supervisory control and data acquisition. So this is the programming tool of automation control system. And in this picture, on this picture, we can see the place which occupies the PLC and level of automation control system which level with a PLC. So let's talk about structure and composition of modern programming logic controllers. So the PLC composition. In the structure of modern programming logic controllers, we have first of all input models, or we call it just inputs. So next, there is the output models, or we call it outputs, and application program. This is the main structure of PLC. In the input models, we can connect any sensors or measuring devices or instruments, and by these inputs we can collect the information from the plant or control object. Then this collected information will be processed in application program. In other words, PLC with application program can process it, and then results of this program will be right into the output modules, and these models will give the information to the actuators. This is the simple structure of PLC, and this is the main idea how works the PLC. So let's talk about types of PLC. First of all, we need to say that simple PLCs have monoblock structures, as we can see on these pictures. This is types of PLC we call monoblock PLCs. It's the small devices which we use for automation of small control objects. So next type, and this is the basic main type of PLCs which we use in most of control objects, we call modular PLC. They have more complicated or more compound structure, because this is the aggregation of different types of models. So in this picture we can see modular PLCs. So let's talk about types of modules. First and main module is CPU module. So next important module is power module. So next we have communication modules, and next type of modules, it's input and output modules. So this is the examples of these models we can see in this slide on this picture, and whole aggregation of these models we have modular PLC. So next type of PLC we call distributed PLC. This is the aggregation of several PLCs, more than one PLC, which we use for automation of distributed and complex control object. So this is the one next example of distributed PLC. So let's talk about programming languages which we use for programming PLCs. So the primary information about PLC programming languages is next. First of all, we need to say that in 1979, at a meeting of the International Electrotechnical Commission, the standard was adopted. The standard is adopted by IEC 61131. This standard consists of 7 sections, and the third section of the standard is intended for the PLC programming languages. So in this part of the standard we have next programming languages of PLC. We have two types of programming languages. It's graphical languages, which contain ladder diagram, functional block diagram, and sequential function chart. And next type of languages is textual. So this type of languages contain two languages. First of all, it's structured text or ST language and instruction list. So we can say that this standard contained 5 PLC programming languages. So let's talk about programming languages in more detail. So ladder diagram. On this picture we can see the fragment or example of using this programming language. Yes, it's look like old relay circuits, and we will talk about in more detail about this language at our next lectures. So next graphical programming language is functional block diagram or FBD. This is the picture which gives for us more information about FBD language. It looks like digital circuits from electronics. Next language is sequential function chart. This is the picture which shows us about more information about this language, and we will discuss about this language on our next lectures. And on this slide I will show you information about textual languages. So next fourth language is structured text, and this text contain program commands looks like C++ or BASIC or Visual Basic. It's very close to standard text language. And instruction list, this is the last programming language. It looks like assembler. So this lecture we in this course I meant in this course we will use the codices program which allows us implement some programs. And on this picture we can see the structure of our codices program. It's example of codices version 2.3, and we will use it for programming our PLCs. So, and this part of our lecture we need to say about how can we need to know in detail program execution in the PLC. So it's cyclic execution. First of all, PLC read inputs which contain information from plant or control object. Then this information will be processed at application or execute program, and then result of application program will be right into the outputs, and this program execution will be executed cyclically. So this is the main cycle of PLC. So thank you, and on this lecture we received some information, primary information about PLC, and I will tell you in more detail about PLC programming languages we will discuss on our next lectures. So goodbye, good luck.